Hello, everyone. Welcome to our webinar today. This webinar is being presented by Clean Energy Group, and the topic for today's webinar is Beyond Lithium, Part 3, Form Energy's Iron Air Battery. The date today is August 6th, 2026, and we have an excellent guest speaker with us today, but before I pass it over to them, I'd like to go over a few webinar logistics. All attendees are in listen-only mode, so your webcam and microphone are disabled. The chat function is also disabled, so if you would like to submit questions and comments, you can do so via the Q&A panel. We will be saving about 15 to 20 minutes at the end of the presentation to address audience questions, so please feel free to type your questions into the question box as you think of them throughout the webinar, and we'll get to them at the end. Automated captions are available using the CC button. Speakers' bios will be made available in the chat. And finally, this webinar is being recorded, and we will email you a webinar recording within 48 hours. It will also be posted to CEG's website at cleanegroup.org/webinars. And with that, I'd like to pass it to our host for today, my colleague Seth Mullendore.
Great. Thank you, Zareen. And thank you, everyone, for joining us today. We've got a lot of people on the line for this one, and it's going to be a really great presentation. So just a little bit of background about us, Clean Energy Group. We've been around in the clean energy space for about 30 years. And our work is all aimed towards a vision of affordable, reliable, clean energy for all. In that goal, towards that goal, we work across a number of different areas. And really, we work in providing a lot of technical and policy and advocacy support to advance equitable and inclusive clean energy policy and development and the transition away from fossil fuels. So a lot of our work is also in the innovation area. Next slide, which is really a focus of the webinar today. So this is part of our Beyond Lithium webinar series, where we're looking at emerging or some more established now technologies, energy storage technologies that are expanding the grid's capacity beyond today's lithium-ion batteries, which dominate the landscape. So this is the third in our series. We're going to keep doing them as long as we keep getting other providers and new technologies to be a part of that. So we don't have a part 4 lined up just yet, but stay tuned. We will have one coming and plan to keep offering those about every other month. So today we're going to be talking with Form Energy about their iron air battery system. I'm sure many of you have heard about Form. They've got a lot of big projects in the pipeline, and it's very exciting. Definitely a leader in the long duration space. And with us today, we have the honor of being able to speak with Sarah Jackson, who is the Director of Government Affairs for Form Energy. In that role, she leads Form's policy and regulatory strategy to develop markets for multi-day energy storage. So with that, I will turn things over to Sarah.
Thank you, Seth. Thank you, Zareen. I'm going to share my screen. Are you all seeing my presentation?
Yes, looks good.
Excellent. All right. Yeah. Thank you so much, Clean Energy Group. Thank you for having me in this series. It's exciting. I know folks from the other companies too. I think it's a very exciting space to be in right now. And so I'm glad to be able to talk to you all about Form Energy and our battery, which I think may be in a more unique space in this sort of sector than maybe some of the ones you've heard about so far. So without further ado, I'm going to go through some of the pretty pictures, but I'm just going to give you a little bit of an intro to the company itself. So Form Energy is an American company. We were founded here actually in Massachusetts, where I live, back in 2017. And we really are about driving innovation in energy technology and manufacturing. Today, we employ close to 1,000 people across the US, spread between our offices in Somerville, which do a lot of our R&D, our offices out in the Bay Area, which do a lot of our engineering research and development, and our sort of world-class, first-of-a-kind manufacturing facility in Weirton, West Virginia. The company was founded in 2017 by a number of energy storage veterans. So our leadership has been doing this for a long time, has a lot of experience in the energy storage world. And I'm actually going to blow up our investor page just a bit to give them a little bit more of a shout out. We have about 1.2 billion in venture capital that's been raised to date. These investors include Breakthrough Energy Ventures, GE Vernova, T. Rowe Price, big investors who really believe in the mission of the company, and that multi-day storage and long duration storage are going to be a really important key to the next chapter in our energy world. But I think really what you guys all want to hear about is the technology itself. So I'm going to dive into a description of that now, and I want to just start out by saying that I said we're an innovation company. Our first product is an iron air battery system. This system delivers multi-day energy storage, and we have a duration of 100 hours with our storage product. Really, this is the duration that we saw as essential for meeting growing energy demand while stabilizing the grid. And we can get into that a little bit more. I know you've had a lot of sessions on the need for this kind of technology. I will say, unlike lithium ion batteries, one thing that's really exciting about Form's batteries is that we do not depend on vulnerable supply chains. We depend on domestic supply chains, and most of our supply chain capacity is from the components of our battery are essentially iron, water, and air, which you can find anywhere on Earth, and are very low cost components. The cost is going to be very competitive, and we are targeting a $20 per kilowatt hour price at scale when we become a fully commercial scaled product. So let me get into what it is. Our batteries work on a principle known as reversible rusting. So the diagram here gives you an explanation for how this works. Essentially, when we're discharging the battery, we are taking metallic iron in the battery and reacting it with oxygen from the air. So the battery breathes air in when we need to discharge the battery, leading to a chemical reaction to form iron hydroxide, otherwise known as rust. When we need to recharge the battery, we run an electric current back into it, reversing that whole reaction. So essentially, we take a rusty plate and unrust it back to metallic iron to get the battery recharged. And that process can be undertaken over and over and over again. It can hold energy, so up to 100 hours, as I said. That's about 4.5 days of discharge at full capacity that can be sustained by this battery. And so that means we can really shift power from, when there's an abundance of cheap energy, we can shift it and save it and shift it over to when it's most needed on the grid. This slide is going to give you kind of some pictures of what the battery looks like. So these are the different components. The first one on the left, I don't know if you can see my cursor, but I'll try, is, essentially the parts that make up the cell. And so this one in the next one over is the cell. And the cell is the building block of our battery system. It's the smallest functional unit. Inside every cell, you can find an anode made of iron, and that's going to be a negative electrode. And then you have two kinds of cathodes that diffuse air into the battery. You also have this cell filled with a water-based electrolyte, and that's what helps conduct the battery. These components stack together to create a module, and then you put a number of these modules inside of a tower. You put your towers inside of a pack, and the pack ultimately is what gets shipped to customers, put together at whatever configuration you need to meet the size that you're looking for, and that is your power plant, your battery plant. So that's sort of way over here on the right is your picture of what a number of these packs all together might look like out in the world. One really exciting thing, you don't need to understand everything on this slide, but what this slide is essentially telling you is that our batteries are really designed to be safe. They are the chemistry itself is inherently safe. It's part of the design. So unlike other battery chemistries that might undergo thermal runaway, which is a process where heat builds up uncontrollably and can lead to fire hazards, our batteries prevent thermal runaways basically by using a water-based electrolyte and having a very stable reaction process. So a lot of these numbers on the side will tell you the different certifications and standards we designed to. In late 2024, our technology successfully completed the UL 9540A safety testing, which demonstrates the highest safety standards with no thermal event or flame propagation. So it's a very safe technology. It's basically iron, air, and water. So it gives you a sense of just what the battery really entails. One of the most exciting things for me is I started at Form in 2023. And this picture here is what was on the ground in West Virginia in 2023, which was an old torn down steel mill. Now, in the course of a year, we built our first factory. This is in the heart of the Rust Belt. This is in Weirton, West Virginia, in the panhandle of West Virginia. So it's actually quite close to, not only the West Virginia steel country workforce, but Pittsburgh, Ohio. It's in that area out there. This is our first high volume battery manufacturing facility. The factory was built in about a year, as I said, and it's about 500,000 square feet right now and growing. We have, over the course of the time since the factory came online, we have about 400 people working there. We expect to almost double that when we're at full scale. And the factory itself has been operating since about 2024, late 2024, to bring batteries to our customers. So we have achieved significant improvements across all the lines within the factory. We've built over 100,000 electrodes. That's the equivalent of 60 miles of material running through the factory. So we've done a lot of work so far in a short amount of time. And essentially what we think the factory does is demonstrate at scale that advanced manufacturing can be achieved rapidly right here in the US. Just to show, we have a lot of commercial momentum with Form. Our first battery packs were shipped to our first customer site, which is Great River Energy. If you can see my cursor, I'm circling it. It's up in Minnesota. Those packs were shipped out last year. We have a backlog of about 800 megawatts or close to 80 gigawatt hours of battery storage project under commercial agreement. And so this list shows you who we're working with across the US. We actually also have a project that was announced recently in Ireland, our first international project. So we have a lot of a momentum, a lot of support from customers and from states who've offered grants to advance this technology. I'm going to get into a little bit about why we're here with a 100-hour battery product. I think most commonly we know lithium-ion batteries, which live in the 2 to 4 and are getting a little bit, up to maybe 8-hour space. I know you've heard from a couple other companies that do long duration storage, which is generally defined as 10 hours plus. But Form lives in a different space where we are in a 100-hour space, or we can operate for 100 hours, and we call that multi-day storage to differentiate it from some of the other types of technologies that you see. And, the challenge, everyone's familiar with the challenge. We have exponential growth in demand coming from manufacturing and decarbonization and electrification, but also AI data centers. So I think we're all familiar with how quickly the demand for power is growing. We're also seeing a lot more renewable energy come on the system, and that is great. It's the lowest cost form of electricity, but it's also intermittent, which means it's hard to always have it when you need it. And that's where storage really comes in. We're also just seeing a lot of storms and a lot of new extreme weather events that are driving the need for a more robust, a more resilient and reliable grid while we're facing some of these other challenges. I'll skip through these somewhat quickly because I think it sounds like you all are pretty familiar with these problems. Load growth is leading to a lot of strain on the grid across the US and across the world. As renewables come in, they're becoming a much greater percentage of our electricity, but they don't always provide energy at the exact moment it's needed. And as I said, when extreme weather is driving not just costs, like you can see on the left here, where we're having a lot more billion-dollar storms coming through, but just leading to a lot more challenges with the grid and our kind of existing infrastructure being able to support that grid. I'm sure everyone recalls the terrible storm Uri that the country experienced a few years back, and just how much of a gap we had and how much need there was to support the grid over multiple days. And one thing that maybe I haven't mentioned, and that I don't know how much we talk about it, but a lot of the resources that we have historically depended on for reliability are retiring. And I think that as those resources retire, we need to have something that can fill that same operational space. Like what can we do that will support the grid over those day-long stretches when we often turn on these coal, natural gas, and oil peakers. And if you're in the Northeast, we have oil peakers here. Those are the resources that keep the grid going in those extreme events, and we need to be able to replace those with resources that can do the same thing because they're retiring. And finally, this is actually a slide just showing how impactful data center growth is on the country as a whole. And I don't think we see as much data center pressure up here in the Northeast, but we are seeing it across the country, and it's a key driver of this need. So jumping right into the opportunity we see as a company and with a 100-hour product, we mentioned this, you've seen a couple of these graphics already, but the grid is really vulnerable to multi-day reliability risks. You see it across all the different RTOs are all calling out this need. Winter reliability is a big concern, and just resource adequacy in a number of regions of the country is really being challenged by these multi-day events. Here you see in New England, you'll see this is when the winter wind can be at a lull for days at a time. The center graphic is showing kind of a back-to-back demand in a heat wave in California. And over here, again, you have this classic winter storm Uri example with just some deep need for multi-day support and firm power. This is sort of our solution to that multi-day problem. This is a graphic that shows you the magnitude of energy you can get from a battery like a Form battery over the course of a year. This graphic represents two 10 megawatt, so small systems, 10 megawatt systems. One down here in purple is a lithium ion system of 4 hours. And you see that this system cycles every day. It is extremely useful for shifting that sun into that evening peak when we desperately need that power and shaving that duck curve down. So this stuff is critically important for that daily cycling task. This same size battery, 10 megawatts, in a multi-day storage product like Form Energy's iron air battery, just holds a lot more energy. So you see that you have about about 40 megawatt hours of energy inside this battery. Ours will hold up to 1,000 megawatt hours. And you can see this battery starts at about a 50% charge. And across the course of a year, you can see the way it's used to really shift energy into different portions of the day, of the year, of the season. So you'll see, sort of net charging over the shoulder months of May. And then this is in California, so this is not going to look exactly like what a New England battery might look like, and you'll see these deep discharges at time of need in summer months where you have heavy need for cooling. And also you'll see the same kinds of things happening in the wintertime, even in California. I think this would be a lot more pronounced if this were a New England state of charge plot. But this gives you just a sense of how this is really a tool to be thought of as sort of a reservoir. Multi-day storage is a big, big reservoir in a small package to provide a lot of energy when it's needed and shift it around to different periods. But I want to make clear that this is not in place of lithium ion or short duration storage, which is, as I said, critically important for shifting energy within a day. It's fast, it's efficient, it's able to do that job really well. Multi-day storage, like a form battery, is just a different use case, and these are complementary roles. So a form battery will shift energy from a low value period in a season to another period of time, and it works as a fundamentally different product, and therefore we want them to be thought of differently. This is not storage, this is short duration storage that has a very important role. Multi-day storage, a different, very important role on the grid. So this is just an example from a Department of Energy, the Pathways to Liftoff for LDES report. This shows you that essentially the DOE sees a need for multi-day storage that stays pretty steady, doesn't seem to fluctuate much in with respect to lithium ion prices. So these two graphics on the sort of center right of the slide, they show two different cases where lithium ion is sort of maintains a certain cost, and then the lower portion is where lithium ion costs just go way, way down, and lithium ion becomes very, very cheap. And you see that between these two scenarios, you still have a lot of need for multi-day storage. And that's because they play very different roles. And so even if we have cheap lithium ion available, you're still going to need this resource that can provide that multi-day support for the grid. I want to talk a little bit about policy drivers that are also leading to, we've seen a lot more need for and recognition of the need for multi-day storage. So this graphic summarizes a few of the states across the US that have put in place either mandates or targets for not just storage. These states also have robust targets for short duration storage. These are states that have put in place targets for long duration and multi-day storage. So you can start to see that need for a multi-day product reflected in the policies of different states. Over here on the right, you can also see the values that different utilities or RTOs are assigning to these technologies. And it's new enough that not everybody's given an accreditation to multi-day storage, but it's coming. And I think that you're starting to see its value show up in different places based on the need that we keep seeing across the US. And, oops. I also just wanted to reflect on the fact that this is not a US phenomenon. We're seeing this demand for longer durations of technologies all across the world. These are some callouts where we just wanted to highlight the demand for multi-day storage, long duration storage, all across the world. So I think, one of the greatest benefits of storage in general, and also our product, our iron ore product, is just the speed to power that it can provide. We can be, contracted and built in just a few years. And, you start to see the other resources that are in this space, in this, sort of peaking power space. And there just aren't those resources available in the near term that can do that job. So I think this is my last slide. The last slide I want to cover is really, I was asked to sort of explain the barriers. I want to explain the barriers by kind of explaining the opportunities. So I'm going to do a little bit of both and say, a lot of the barriers with a brand new technology is just folks not understanding how it works yet. And, I point to planning and making sure that modeling, utility models RTO models, even the models that folks like CEG employ, a lot of them aren't built to account for resources that can operate over multiple days. And so a lot of times the value of these resources isn't captured in the models. And so I think we are doing at Form, and I know a lot of other folks are working with the modeling companies themselves, with the utilities, with other organizations to try to build that capacity and that knowledge and to adjust the models to be able to account for what multi-day storage can do. I think you also have to look at how you value the reliability benefit that these resources can deliver. And one of the ways I mentioned on the previous slide that one of the ways that this is happening is through the accreditation process. And we've started to see some really positive accreditation values come. There's just also a lot of market rules and market designs that need to change to better account for the value that these resources bring that isn't currently built into those systems. The next piece here is about program design. This is sort of referring back to state procurement programs or incentive programs. And a lot of times these are not designed to necessarily account for the duration of a product. A lot of times these programs pit storage resources against each other from different categories. So you'll say, well, what's the cheapest storage technology? Are you looking at that on a per megawatt basis? Are you looking at that on a per megawatt hour basis? And whichever basis you use will sort of define which one you select in the end. But they shouldn't be working against each other. We should be looking for the qualities we need, for the benefits we need, and valuing that and designing programs that will achieve both the short duration peak shaving capabilities and the long duration sort of peak backup, multi-day backup benefits that we need. And then, I think the same thing is true when you look at deployments, when you're looking at requests for proposals and what's coming out of integrated resource plans. You need to make sure that you're designing those programs to be inclusive of these technologies, of new technologies and the capabilities they can deliver. And, a lot of what we're doing is utility engagement. We work with our utilities, our customers, but we also work with them to help them understand how this technology can be a benefit and how they can design programs that will help support and deliver those benefits to their customers. So those are sort of, you can infer the barriers by what the fixes are that I wanted to highlight. But that's, it brings me essentially to the end. And I know that we have Q&A, but I wanted to just take another minute to thank you all. This is a really exciting space, and I love to be able to come talk about Form and about our batteries, and happy to be here with Clean Energy Group.
Great. Thank you, Sarah.
Do you want me to stop sharing the slides, or should I leave them up in case?
Yeah, it's I don't know, it's up to you. I maybe stop sharing, and then if you want to have them back up, I think Zareen, or we can get them back up for you. So
okay.
So yes, it's a great. We have a lot of time here because we have a lot of questions for you, and we have very good questions too. I'm actually going to start not with the first ones, but I'll get back to you, folks. Don't worry. But there's kind of a flurry of questions that came in towards the end because I think people were like, "Wait, I wanted to hear about this. I want to hear more about this." So there was a number of questions that came in around the end, just about what's the status of current projects. So I mentioned Great River Energy Project specifically. I don't know how much has been installed right now. Is there anything actually operational? And what does the near-term pipeline of projects actually look like?
Yeah, I'm going to bring the slides back up because
it
would actually be helpful to go back to that. So I'm sorry, I don't want to give anyone whiplash. So I'm going to stop sharing just long enough to get my slides back onto the right one so I don't make you go through it. I had the slide that showed our different projects. I can't find it on my screen right now, so I'm gonna make you guys go with me on this journey through the slide deck. So I'm gonna go back, but we had the list of projects across the country. Oh, sorry. Here it is. So I think I mentioned that our first deliveries were made to Great River Energy last year. The I have a quick note on it. So those batteries were deployed. They were actually we put those in place during the polar vortex that hit Minnesota. So it was bitterly cold, and that means we got to operate those batteries at probably one of the worst times, and they worked, and that was really important. So I think that was just part of the product. The rest of the project will be delivered a bit later. We're actually working in California to deliver the very first utility scale project out there. And we have that one will be trying to look for my date on that one if I have it. May not have the date for that one. Soon. I'm going to say soon, just because I can't find it in my note right now. But then you see the rest of this list, and those are all coming in the next few years. These batteries will be sent out to customers. So I think the success of the manufacturing facility and the scale and ramping there is really it's driving these projects to be, coming quite soon.
So another related question I saw that came up, you mentioned those were installed and operated in very cold temperatures. Do you have at your fingertips the operating range, the temperature operating range for the batteries?
I don't have it at my fingertips. I know it's a very wide range. I know we've tested them in very cold climates. I know that they're capable of operating under very hot conditions as well. I'm sorry, I don't have the exact specs at my fingertips.
Okay. So now I'm going to go back up. This was early on. You mentioned that these are water-based. Water is a big component in this. So there was a question about, is there any water consumption throughout the year? Does any water need to be added, or is there water that goes out of the system? Water availability is a big concern for a lot of areas of the country.
Yep. Yeah. And so because it's a water-based electrolyte and because the batteries breathe, you do get a little bit of respiration. So you do get some need to refill that. The usage is, I think, by comparison to, I guess it depends what you're comparing it to. So comparing it to an existing peaker plant, you're going to see a significantly less water use. But so they do still need, because of being a water-based electrolyte, there is still some need for water in the batteries.
Right, and I get related to that. How does that impact the maintenance costs for the batteries over time?
So that the maintenance costs are fairly straightforward. I think they're what you would expect. I don't think I have the costs directly at my fingertips. So I think for a lot of these details, if folks do want to know more, you can reach out to me and I can connect you with our business development folks or our project engineers who can get into a little bit more of the nitty-gritty details of the system, can probably give you that range of temperature and can give you a water usage number too.
Great. Back to the fire safety side of things. You'd mentioned, the thermal runaways, the risk is not there for that. Were the batteries tested for an external fire? So a fire happens in the region or at the facility, and how the batteries are impacted then if it's a fire. Not that the batteries cause themselves, but say there's a wildfire in the area where they've been installed.
Mm-hmm, mm-hmm. So I guess I probably shouldn't answer that because I don't know the answer specifically, but I am going to venture to guess yes. I know that should a fire occur, the firefighting techniques that are needed are straightforward. It's water, it's not foam. So I think that I know that that's a concern. Where I live, there's been concerns about firefighting. And so I think that is an element. But again, I think the details around if an external fire were to come in and affect the battery, essentially the battery just stops. If you stop running the chemical process, it just stops doing its battery thing. So
yeah, great. A couple of questions about scale, just scaling down. Most of your installations are going to be, at that megawatt or upscale. Is there an opportunity to do uh, farm batteries at like a community scale kind of installation, like perhaps a microgrid? One person even asked about the applicability for electric vehicles. So, any thoughts on those?
Yeah, I mean, I can say I think that's an exciting potential future, but I think so originally this technology was developed in the 60s, or discovered in the 60s. And originally the idea was, could we put it into car batteries? The truth is these batteries are really big and really heavy because we use iron, which is heavy. I wonder if I have if I go back to the picture, you use iron, making these things really quite heavy. You then add a water-based electrolyte, adding a bunch of, liquid weight. So this is not really the kind of technology at this point that's going to be able to be used in cars. And I think in the 60s, they kind of shelved it, saying, well, we can't use it for small applications. I think as we scale, we're really targeting the grid connected multi-megawatt space at the moment.
Great. That's a good lead into this question. Can you tell us what is the footprint? Person asked specifically about a 50 megawatt power plant, but if you happen to have a number available of like what is X amount of megawatts, what kind of space does that take up?
Yeah, so the initial product here is you can fit about 2 to 3 megawatts on an acre. We're always working in our R&D department to iterate and improve that number. It's a little bit more energy dense than lithium ion, but quite a bit less power dense. So you can fit more megawatt hours on an acre, but fewer megawatts on an acre, if that makes sense.
Yeah, that does, just for people that don't want to do the math. So we're talking 2 to 300 megawatt hours then per
On an
acres.
acre,
Yeah, yeah.
correct.
Which, yeah, I think that's a much yeah, I think that number will mean more to some folks than the 2 to 3. Or at least to me, it's yeah, it's a good number to be able to call out. So a couple of people asked about, so you said these can be used over and over. So what is the life cycle, or the warranted life, I think, of the batteries?
Yeah, with a brand new technology, we're still learning and iterating. But essentially, right now, we guarantee the batteries for at least 10 years. I think our expectation is that these can last longer, but we're still learning there, and so the hope is that it will be a longer lived asset.
Do you have a cycle life number as well?
Yeah, let me look at if I can get back to the little graphic that shows how they work. I think it says on here. Oh, no, it doesn't. There we go. This one does. So,
Oh,
yeah, we look at around 8 to 13 cycles per year, and just keep in mind that a cycle in a multi-day storage battery is a lot different than a cycle in a lithium-ion battery. So it's sort of cycle equivalence across the year.
great. Yes. And there was a question specific to that. Is, how do the economics work if there's only 8 to 13 cycles per year? Which I think is important to note, that that's the full. If you were to do the full discharge, and you showed that through a lot of the year it's operating, but not to full discharge capacity.
Yeah, so I think the easiest way to look at it is, that figure that I gave at the beginning, which is that we're targeting $20 a kilowatt hour for the energy. And so if you look at that cost, and you can compare it to maybe a gas simple cycle turbine, what would the cost for energy be from one of those? You kind of get a similar, because it operates similarly. It's something that you're not going to run this the way you would run a lithium ion battery for sure. It wouldn't make sense, but for what you need it, to be there when you need over the course of multiple days, to help shift wind lulls, or to cover wind lulls, or to cover winter storm needs. So it kind of fills that same role. Um, I think, do you think that answers the question?
I
He's
think it
smiling.
answers it probably as well as you're able to, at this point. Question about ramp rate. So, what's the how quickly can the batteries ramp up?
They're quite flexible and rampable. I know whoever asked this question is probably looking for a minute figure, and I'm not sure I can give it off the top of my head, but I know it's quick. I don't think it's quite as quick as lithium ion, but it's quick. But again, like I want people to follow up if they have these specific numbers that I'm not able to give, because I can get them for you from our team.
Great. This is an interesting question. I'm curious about the answer. So I know these are designed to be 100-hour storage, but there was a question of whether or not the system could dispatch at a faster rate to provide a higher power.
Um, I think so. I'm not going to answer because I don't know the answer. I want to say I think the answer is yes, but I'm going to make sure with my team before I commit to that answer.
Great. And we had somebody who self-identifies as an engineer who just wants to know, is there
Uh-oh.
somewhere they can go to get more information about the actual process, the engineering side? I don't know if that's information that Forum has on their website or not.
I would say you can start with the website, but also I'm going to provide Seth and Zareen my contact info. So feel free to reach out to me, and I can connect you with the right resources to get these answers.
Great. Okay. If I covered some of
I
these.
talked too
So,
fast, Seth.
well, no. I'm done. Actually, questions are piling up faster than
Okay,
there's
okay.
we're answering them. But we got to some duplicates in here. A question came in, and I'm curious about this too. Yeah, has there been any challenges that have emerged as you've now been installing the systems and actually operating them? Are there lessons that have been learned throughout that process?
I mean, certainly we're always learning, and being in the early stages of deploying those first projects, if we weren't learning, we'd be doing something wrong. So I think we've iterated on a lot already. I think I mentioned how many cells we've built and tested. I have a figure here that I wrote down that kind of talks about. Here we go. It says to date, we have tested tens of thousands of subscale cells, thousands of full scale cells, over 200 modules, and 10 plus grid connected packs. So we've found a lot of great results. And obviously, it's helped inform the product that we have today and the product that we continue to develop. So I don't know how to say, I don't think I can
Yeah.
say exactly what we've learned. My engineering team could, but I can't
Here's
necessarily
a
speak
question
for them.
I knew would come up and we talked a little bit about beforehand. But they're asking, how does the cost compare to lithium ion batteries on a per kilowatt hour basis?
So I think the easiest way, I mean, I can kind of refer back to the target cost that we're looking at, which is $20 a kilowatt hour. Um, Honestly, folks on the call might have a better sense of this. I believe it's about 10 times cheaper than lithium ion currently is for that energy. Um, so I think maybe but that's only one figure, that's only one way of looking at it. So I think there's going to be other ways you can compare, but again, it kind of gets back to that apples to oranges. What do you need? What service are you looking to have met? What are we providing? And the services are just very different, so it's not always an apples to oranges comparison.
Okay. Um,
Apples to
so
apples.
considering the backlog of projects that you have in the pipeline, does that impact your speed to delivery of projects right now?
Um, so what we tend to say is that our manufacturing capacity is sold out for the next couple of years, like the backlog or the sort of the under agreement projects that you saw listed on that slide. are going to keep us busy for the next couple of years. But we're growing and targeting being able to deliver more in the next few years. So certainly, you couldn't probably buy one tomorrow to be installed tomorrow.
Mhm.
But we certainly have are turning towards expanding our manufacturing capacity, being able to meet those needs. So that's really the driver is the demand for this. So that's where we're going.
Yeah, and I'm sure that's another case where folks are trying to buy one for tomorrow. You can reach out to Sarah. And yeah, I know, Zarina, maybe if Sarah, are you okay with us sharing your email in the chat?
Please, yeah, yeah.
Yeah, yeah. Zarina, if you could do that, then folks can reach out to Sarah directly too. Here's a question that I don't really understand, but it comes from the Boston Fire Department. So I feel like I should definitely raise it because they're doing great work. Any risk of spontaneous combustion with iron sulfide production? Does that mean anything to you, Sarah?
Um, it does not. Let me grab the. I've not heard of that, so I'm going to say I think no.
Okay.
I think as I mentioned, we completed the UL 9540A safety testing. The fire department may know better than I do what that what that might mean, but I think that the main takeaway from that was that there were no flame or thermal event propagation risks. So
Yeah.
if that answers the question, if it doesn't, please reach out and
Yes.
I can make sure to get the actual answer.
Yes. So, Chris, if your question's not answered, please do reach out. I know we've, in our work, have talked to Boston Fire Department folks around lithium ion, where they had some concerns around siting of that. So, this may be just trying to get a handle on what that would look like.
Sure. Yeah.
Question about round trip efficiency. If you can speak to that, what the round trip efficiency of the battery is, and if there are any steps that Forum's taking to try to improve round trip efficiencies. I'm sure that's an ongoing process.
Yeah, I think, and round trip efficiency comes up because the longer the duration, often the more trade-off you give with long-term round trip efficiency. So we are always working to improve that. I think, our R&D department works really hard to make improvements. I think that it's sort of more important to focus on where the value comes in from this rather than, can it efficiently cycle every single day like lithium ion? I know they have more of a, I'm not a lithium ion expert, so I'm going to say 85% round trip efficiency. We are significantly lower than lithium ion, but we are a multi-day asset. It's a trade-off. We optimize for cost-effective scale, not necessarily peak efficiency. So, I think we kind of love analogies. My boss loves the analogy of when you have a running team or a running team, you have your sprinters, they do one job, and you have your marathon runners, they do a different job. Their running looks real different from each other, but they're both really important members of the team. So we're kind of we're the long distance runner. We take our time. So I think that, maybe that's an analogy that lands with you. I'm not a runner, so it doesn't necessarily always land with me. But I think with grid reliability studies, what we're seeing is that the highest risk periods are prolonged stress events, heat waves, renewable energy lulls, kind of shown on this guy here. It shows you where we just have a lot of big risks in these areas, and we can reliably show up for those. And so I think we tend to say the efficiency is not the most important factor when you're looking at these kinds of events.
Right. So I think this is kind of a related question to that. I mean, most of what you're showing as far as the application for this, it's really providing that capacity during those grid stress events. There's a lot of other things that lithium ion has been called, Swiss Army knife. It can do all sorts of things. This person is specifically asking about things like voltage ride through and load smoothing. Do you see that as part of the list of services that Forum's batteries will provide, or is that more like lithium ion's got that covered. We have a different value proposition.
Um, so, I think there's a lot of services we can provide. I think going back to this slide, you see in the little explosion down below, you can see we're not just a smooth line going up and down. Like we can provide services during the day that are similar to a lithium ion battery where you kind of, draw a little out, put a little back in throughout the day on a cycle that can deal with those fluctuations intraday. It's not the main use case for the battery, but it can still be used that way. You'll also see on this graphic, which I didn't highlight, but the kind of red dotted box, that is, you could program the battery to hold a reserve. In this case, we did 24 hours. So this battery was told keep 24 hours in reserve at all times for use, for future to be called upon. So I think ancillary services, are all something we can provide. I think it's just going to depend on whether it's the most effective option for the use at the time. So I think I wish I did have that ramping rate for you all because I could say sort of what the capabilities are there. I know we can ramp very quickly, so there's some ability, but if lithium ion can ramp more quickly, that might be sort of the technology of choice. But I do think there's just a lot of ways you can use this battery. We tend to think of it as this is a peaking battery, right? This is going to provide the same resources, the same operational capabilities as a peaker plant does now.
Yeah. Yeah. And for those folks that I imagine most folks on here are familiar with peaker plants, but I mean, many of these operate just, less than 100 hours a year, in some cases. So, at less than 1% of their potential capacity. Most of them are 5% or less. So if you think about how do you have a power plant that only operates that often, you can start to think about the value proposition, I think, in those kinds of terms, and without any emissions. So there's that. So I am seeing now some more questions on the cost side. To the extent possible, I mean, can you talk about the trajectory towards that $20 per hour kilowatt hour? Like, if you can, where are you on that trajectory, and kind of what's the anticipated timeline to reach it?
I can't offer forward projections on costs, but I can say, that cost target is grounded in our inherently low cost of our materials. Iron, very cheap and abundant material. We have made significant progress down the cost curve as we've moved from R&D to our high volume manufacturing, and we're going to continue to drive those costs down. I would say, we've started commercial production in our factory, and we have over 800 megawatts of, customer agreements in place. So as much as I can't necessarily give you a specific point on the curve that we're on, I can say all those things and hope that it points you in the direction, where we are, where we're headed.
Great. So I was waiting for this one. There was a question about a component sourcing and eligibility for, say, federal tax credits for an entity of concern exposure. Like, can you talk about that?
Yeah, I can. So and I think I did not include that slide. So our supply chain is around 85% domestic at this point. We really don't, we are eligible for the tax credits, including the domestic manufacturing tax credits. Our sourcing does not have, we don't have FIAC, the foreign entity of concerns. So we don't really have a lot of concern there. Right now, I would say our not everything is sourced in the U.S., but that most everything that that can be purchased here is. We make a lot of our, we do a lot of the assembly of all the components. We create the product in our factory. So, we really build out much of the battery at Form Factory 1 in West Virginia. And so, that makes our control over the process and over the battery components pretty high. Um, yeah, I think maybe that if there's follow-ups, I can try to answer follow-ups. But yeah, large portion is domestic, and the rest is from allied countries.
Great. Okay, I'm going to try to sneak a quick one in because I see two now. Um, is there any active heating or cooling that's required for, more extreme temperature environments?
The batteries themselves, you can actually see on this picture. You can see the little vent systems. They have HVAC systems like any other battery system. It's just it's air. So I think that you don't want them to. I think in our polar vortex, we probably warmed them up a little. But it's they're essentially pretty well functioning
Great.
in that regard.
This is we have 3 minutes. I'm going to end with a hard one or a longer one potentially.
Oh, okay.
So this is what policies would you like to see
Ooh,
um,
these are the ones I want.
in restructured states as storage goals become more prevalent? What would accelerate deployment? Is it just that there should be some kind of carve out, or is it more nuanced than that? And this comes from Georgetown Climate Center.
Yeah, well, and that's let me see if I can get back to my policy slide. So the ones that you see on the screen here were largely carve outs. And so, I think in the early stages of creating these programs, the carve out is the easiest approach because it looks at what a state or the maybe the utility might need and says, I want a portion of this in let's use Virginia as an example. In Virginia, they said, we want a lot of storage. We have a lot of demand. We need a lot of support. So they called for, I want to say I think it was about 16 gigawatts of short duration storage in that state. Separately, they said, we know that we have this other issue too with needing to cover these long duration events. And so they specifically called for actually not just multi-day storage, but also long duration storage as its own category. So in Virginia, there was a call for another 1 gigawatt each for long duration storage in these timeframes, which is defined as 10 to 24 hours. I think in a perfect world, you might be able to design a program that asked for and compensated for just the services you wanted in just the right way. I think that's extremely complex. And probably pretty hard to do. And so I think that the carve out works fairly well if you can size it to sort of maybe some studies that have been done to show what the grid needs to get to the mix of resources that you're looking for. I think that can be a really good start. You really want to just start the laying the groundwork for getting these resources on the grid, getting them working and showing their value. And then, what you hope is that the market starts to pick them up on their own, on its own.
Yeah. Yeah. I guess I'll just to point to the two largest markets that we have in the US for shorter duration storage, California, which was completely target based, and then Texas,
Yeah.
which is completely market based. So,
Yeah.
one was planned and the other one happened because the conditions were right. So I
Yeah.
think it's certainly going to be a mix. But I see we're at time now. So Sarah, thank you so much. You answered so many questions and we have a lot more. So I imagine you're going to be getting some emails from folks, and we appreciate you being willing to answer those questions. So thank you for your time. Thank you everyone who is on the webinar today. We will have more in this series coming up. So stay tuned for that. We'll let folks know on that. So thank you, Sarah.
Thank you so much for having me.